Here you have an electrical circuit. The current through 8 ohms is given as 0.5 ampere. What is the current through 2 ohms? Let's try to do this. So here is the circuit again. For the circuit shown in the figure, the current in the 8 ohm resistor is 0.5 ampere, and all quantities are accurate to two significant figures. What is the current in the 2 ohm resistor? So here we have the 0.5 ampere, and we're trying to find the current through 2 ohms. So the voltage across 8 ohms is the product of the current and the resistance, so we get it as 0.5 times 8, which is 4 volt. Okay, so that's the voltage across the 8 ohms. Now if you look at the diagram carefully, you see that the 8 ohms is connected in parallel to the 16 ohms, and when resistors are in parallel, the voltages across them must be equal. So now that we know that the voltage across 8 ohms is 4 volt, we know that the voltage across 16 ohms must also be 4 volt. Once we know the voltage and the resistance, we can calculate the current. So let's do that. So the voltage across 16 ohms is the current through 16. See, I'm using I sub 16 just to show current through 16 times 16. That's Ohm's law. Rearrange that and we find the current through the 16 ohms as 4 divided by 16, 0.25 ampere. So that's I16 is 4 divided by 16 is equal to 0.25 ampere. We know the current through 8 ohms is 0.5 ampere. Just now we found that the current through 16 ohms is what? 0.25 ampere. Therefore, these two currents come together and flow through 20 ohms. That means the current flowing through 20 ohms is the sum of 0.5 and 0.25, which comes out to be 0.75 ampere. So that's the next step. So now we know that the voltage across 20 ohms must be the current through it times the resistance. So 0.75 times 20 gives us 15 volt. So we have the voltage here as 15 volt, got the voltage here as 4 and here as 4. So the next step is, what's the total voltage? Remember, when they are in parallel, you should not add these two 4s. The total voltage supplied by the battery is just 4 volt here, because these two resistors can be replaced by a single resistor, and you would get the voltage across them then as 4 volt. So you have 4 volt across that parallel combination, and you have 15 volt across the 20 ohms. That means the total voltage is 4 plus 15, 19 volt. So that's the total voltage supplied by the battery. That's the total voltage of the cell. 4 plus 15, 19 volt. Now that we have that 19 volt, we can look at the 6 ohm and the 2 ohm down below. Okay, so here these are the only two resistors at the bottom, and these two are in parallel. So the voltages across both of them must be equal, just like I said before, and they are connected to the battery, and the battery has a voltage 19 volt. So what's the voltage across the 2 ohms? It's 19 volt. What's the voltage across the 6 ohms? It's also 19 volt. Now that we know the voltage across 2 ohms, we can find the current through 2 ohms. Just divide the voltage by the resistance, again by the application of Ohm's law, and then you get the current through 2 ohms as 19 volt divided by 2 ohms, which is 9.5 ampere. That's how we work out this problem. And I hope you have understood how I have worked this problem out. Let me know, give a like, post a comment, and subscribe. Thank you, and we'll see you on the next video.